So now we'll discuss a new topic called acid, bases and salts. What is acid? What is a base? What is a salt? Acid is one which is having or which is donating H plus ions. Base is one which is donating OH minus ion. This is a general theory that it is acid is one which donates H plus ion, base is one which donates a OH minus ion, and the salt, this is a salt which is formed by the combination of acid and base. Acid and base, it gives rise to salt plus water. Okay, and this salt plus water, this reaction, there is a mixing of acid and a base to form salt and water. This reaction, it is called neutralization reaction. Neutralization reaction. Okay, now to explain about the acid and a bases, different theories has been included to explain the how the acids is defined, how the base is defined by the different theories. One theory, it is called Arrhenius theory. Next theory, it is called Bronsted-Lowry theory. And one more theory called Lewis acid-base theory. Okay. So what are the general properties of these acids and bases? First we'll see acid, it is a sour taste. Acid is having a sour taste. It turns blue litmus paper. Litmus paper is available in all everywhere in the laboratory that you might have seen. Okay, so this litmus paper, it is isolated from a symbiotic organism called lichen, and this lichen, from this lichen, it is taken out. This litmus paper, it is useful for detecting that whether the given sample is acid or a base. So if it is the substance, if it is the solution, if it is changing blue litmus to red, then it is considered as an acid. If it is changing red litmus to blue, then it is considered as an base. Now different theories, I told you that different theories like Arrhenius theory, Bronsted-Lowry theory and Lewis theory, it is explaining about how the acid and can be defined. According to this Arrhenius theory, acid is one which donates H plus ion. Which donates the H plus ion, that is called acid. For example, HCl is an acid which donates H plus ion. H2SO4 is also an acid which donates H plus ions. Including that one, it is donating Cl minus, it is also donating SO4 2 minus. Okay, so acid is one which donates H plus ion, it is called acid according to the Arrhenius theory. But according to this Arrhenius theory, the substances which are having the H plus ions, then they are called as an acid, which donates the H plus ion, they are called as an acid. That means the substances which are not having the H plus ion, even though they are behaving like an acid, this theory cannot explain the substances which are not having the H plus ions. This is applicable to the acids or the substances which are having only the H plus ions in that substances. Next, Bronsted and Lowry theory. According to the Bronsted and Lowry theory, acid is one which donates the proton. Acid is one which donates proton. Bronsted and Lowry theory, it is an acid-base conjugate theory, right? Bronsted, according to them, there is an acid is one which donates proton. Then the last theory, that is called Lewis theory. Lewis theory, it explains that acid is one which donates, which accepts the lone pair of electron. Acid is one which accepts the lone pair of electron. What is a lone pair of electron? A pair of electron which are not ready to participate in any kind of bond formation. For example, NH3. Okay, in this NH3, it is consisting of one lone pair of electron, two dot-like structure. This dot-like structure which is present on some of these molecule, this is called a lone pair of electron. Okay, lone pair electron. If this electron, it is accepted by any substance, say for example BF3, boron trifluoride, right? If it is an accepted, this lone pair of electron, it is accepted by this substance, then this is called Lewis acid. Okay, so the substance which accepts the lone pair of electron or a pair of electron, they are called as an acids. Okay, next uses of acids. We are discussing about the different types of an acid from the different sources. Okay, so for example, Citric acid, it is absorbed in the case of the lemons and oranges, that is in the citrus fruit. Lactic acid, the sour milk, already we have discussed in the previous slides, that is an milk is sour because of the presence of lactic acid. Next, rancid butter, that is consisting of butyric acid. Tamarind and grapes, it is having the tartaric acid. Acetic acid, it is called as an vinegar. This is diluted acetic acid. 5 to 8% of acetic acid is called vinegar. Okay, acetic acid, 5 to 8% of acetic acid, it is called vinegar. So now malic acid, it is present in the case of apple. Carbonic acid, it is present in soda, aerated drinks, all the cool drinks. For example, if you take any thumbs up or Pepsi, all these things, it is consisting of carbonated acid. Okay, then the next, stearic acid, it is present in the fats, and oxalic acid, it is present in the tomato and this wood sorrel. Okay, next, hydrochloric acid, it is present in the digestive system, that it is useful for the process of digestion. This is very important. It is useful. It is useful in the digestive system. The nitric acid, it is used in the purification of gold and silver. Okay. Then oxalic acid, it is used to remove the rusted spot. Right, wherever the rusted process, we can clean with the oxalic acid. So which acid it is useful to remove the rust spot, that is called oxalic acid, and which acid it is present in our body that it is involved in the digestion, that is called oxalic acid. Now the boric acid, it is useful for eye wash. That means in case of, for example, if you take some eye drops, it is consisting of boric acid. Some content of boric acid will be there as in one of the constituent. So the red ants, it is consisting of formic acid. Red ants means whatever the ants that whenever it sting you, what will happen? You will feel the pain. That pain, it is because of it is release of formic acid. That, and the sting, it is consisting of formic acid. We are going to release one kind of uric acid through urine. Mammals, all the mammals including the human beings, we are going to secrete a uric acid, right? Next, one more thing, that is an HNO3 and HCl. The ratio, that is 1:3 ratio. This is called as an aqua regia. This is called as an aqua regia. So this aqua regia, that is nitric acid and HCl, these are in the ratio of 1:3. This is called aqua regia. This is useful for dissolving the gold. Right, any metals can be dissolved by using this combination. For example, if you want to dissolve the gold, it cannot be dissolved in either HCl or H2SO4, or even in the case of HNO3, it is not dissolved. But if we take the combination 1:3 ratio of nitric acid and HCl, it is, the gold can be dissolved easily. It will melt in that one. Right. So HNO3 and HCl, the combination 1:3 ratio, it is called aqua regia. Next, the strength of acid. See, these acids can be classified into strong acid and weak acids, depending upon this dissociation capacity or ionization capacity. If the acid is completely, for example, I'll take an acid in a water, okay, I'll dissolve HCl. So if this acid, if it is completely dissociated in the water like H plus ion, complete dissociation into H plus ions and the Cl minus ion, then it is considered as that is my strong acid. If it is not dissociated, if it is dissociated 5% or 10% or 90%, if it is not completely dissociated, then that it is called as a weak acid. Some of my strong acids are HCl, HNO3, this should be come down, HNO3, this is H2SO4. Right, then the partially ionized water, ionization or dissociation, both are same, a small difference will be there. Okay, then CH3COOH acetic acid, then this is carbonic acid, formic acid. Right, these are the weak acid. Generally the mineral acids, that is which are having the there is an HCl, HNO3 and H2SO4, these are strong acids when comparing to the organic acids. Okay. Then classification of acids. Acids are classified into hydrates, that is anhydride acids, and this is called oxyacids. This is not comes under this one. So this is acidic. This is showing the acidic property. Right, here in this case, this is going to be donate the H plus ion. Here in this case, oxy acid, that the hydrogen, it is in this oxy acid, the hydrogen, the donating H plus ion. I told you that is a replaceable H plus ion. right, as that is an acid. The replaceable H plus ion, it is linked with the oxygen group, so they are called as an oxy acids. So in all these cases, H2SO4 or HClO4, IO4, this is H2SO4, HNO3, HClO4, HiO4, right? This is an chlorate, iodate, nitric acid and a sulfuric acid. So these acids called as an oxo acids because the replacing H plus ion, it is in link with the oxygen. So here directly it is linked with any other element. Next, basicity of acid. What is a basicity? The number of replaceable H plus ion present in an acid, that is called basicity. The number of replaceable H plus ion, that is called acid. For example, HCl. How many replaceable H plus ions are there? Only one. So the basicity of this acid is 1. This is called monobasic acid. Okay, for example, H2SO4. H2SO4, it is having 2 H plus ions, so it will donate the 2 H plus ions. It is called as a dibasic acid. For example, H3PO4, phosphoric acid, it can donate 3 H plus ions, so it is a tribasic acid. Okay, monobasic acid which donates 1 H plus ion, dibasic acid which donates the 2 H plus ion, tribasic acid which donates the 3 H plus ions. Okay, so here one example, that is the number of replaceable or removable hydrogen ion from an acid, that is called as an acidic basicity. So here H plus ions. Okay, HNO3, it can donate 1 H plus ion, H2SO4, it can donate this one, H3PO4, actually this is an tribasic, this is an dibasic. Tribasic, that is a removal of. Okay, then acidic strength in the case of down the group, how it is going to be formed. In the case of particularly halogens, hydrides of these halogens, that is fluorine, chlorine, bromine, iodine. This is combining with the hydrogen, HCl, HBr, Hi. Okay, so down the group, the acidic character of these halogens, it is decreases. That is the fluorine, it is having the less HCl. I mean the fluorine, it is having less acidic character. Hydrogen fluoride is having less character. Then this one, it is having less. Then this. So Hi is a strong acid when comparing to the HF. Why it is so? Because see, basically we know that acid is one which donates the H plus ion. So in this case, HF, I'll compare HF and Hi. Okay, HF and Hi. See, the size of this fluorine is very small, whereas the size of iodine is very big. So once if it is linked with the hydrogen, so being a very small, it is having the more force of attraction towards the nucleus of hydrogen. So this cannot be dissociate easily. Whereas in the case of hydrogen, this is smaller size and the force of attraction towards the, see, this iodine is a bigger size, hydrogen is smaller size. So being a larger size, this hydrogen cannot form a bond, a strong bond as like this smaller size fluorine. So this can be dissociated easily. So which can dissociate easily? That is having the more acidic property. So hydrogen fluoride considered as a strong acid in the case of what do you call the hydrides of halogen. There is an HF, HBr, HCl, all these things. When you compare the Hi, it is having more acidic character because it can donate the H plus ion very easily. Next one, uses of HCl. Particularly we are discussing about the uses of HCl, H2SO4 like that. So I told you already that it is present in the gastric juices, which is useful for, responsible for the digestion. Okay, this is also useful in the bathroom cleaner. Then this is a pickling agent for the galvanization, that is to avoid what you call rusting. We are doing the galvanization, tanning of leather, and dyeing on the textile industry. It is also used in the dyeing on the textile industry. Manufacturing of gelatin for bone thickness, I mean bone fracturing during that case. Okay, then HNO3. Okay, so this is used in the manufacturing of fertilizers like ammonium nitrate and manufacturing of explosives, very important. TNT, trinitrotoluene or trinitrobenzene, and picric acid, trinitrophenol, these three. So these are explosives which are useful. Nitric acid is used in this case, that is a TNT, TNB and TNP, that is a trinitrotoluene, trinitrobenzene, trinitrophenol. Okay, then it is also used in the preparation of the dynamite, that is a nitroglycerin found in rainwater, that is an acid rain. It forms the nitrates of the soil. This is very important. That is for then manufacturing of rayon and dyes and drugs.